What if I told you there exists a colossal structure that completely surrounds our solar system? An invisible wall made of billions, perhaps trillions, of mountain-sized frozen pieces, marking the most extreme limit of everything we know as our cosmic home. Incredibly distant, beyond the reach of our most powerful telescopes, the Oort Cloud remains shrouded in mystery and speculation, where the sun's influence becomes weak as it brushes against the absolute void of interstellar space. What exactly is this ghostly structure? If we've never been able to observe it directly, how do we know it really exists? And why do some scientists question its existence? Today, we're going to unravel this cosmic enigma that challenges our understanding of the solar system's limits. You've probably heard of the famous asteroid belt located between Mars and Jupiter, and perhaps even the mysterious Kuiper belt beyond Neptune. These regions are like rings of debris that orbit our sun in a more or less organized fashion. The asteroid belt consists of millions of space rocks, while the Kuiper belt is a massive field of icy objects that occasionally sends us short-period comets, those that complete their orbits in less than 200 years, like the famous Halley's Comet. But while astronomer Gerard Kuiper was investigating these predictable comets, a brilliant Dutch scientist named Jan Oort was intrigued by a much bigger mystery: long-period comets. Few scientists have made contributions as monumental to astronomy as Oort. In 1927, he calculated our position in the Milky Way galaxy, and in 1932, he was the first to find concrete evidence of mysterious dark matter. In 1950, Oort made a revolutionary theoretical discovery. He proposed the existence of a gigantic spherical bubble of icy debris completely surrounding our solar system, what we now know as the Oort Cloud. But unlike the other belts, this structure has never been directly observed. What led Oort to this audacious theory? Unlike short-period comets, such as Halley with its 75-year orbit, long-period comets were completely unpredictable. Some took up to 30 million years to complete a single orbit. Even stranger, they arrived from all possible directions, with completely random orbital inclinations. It was a puzzle of cosmic proportions until Oort discovered a fascinating pattern. All these mysterious comets had something in common. The most distant point of their orbits, called aphelion, consistently clustered around 50,000 astronomical units from the Sun. To get an idea of this absurd distance, remember that Neptune, the most distant planet, is only 30 astronomical units away. These discoveries revealed three crucial facts. The comets didn't come from distant interstellar space, their orbits clustered at a specific distance, and they arrived from any imaginable direction. Based on this evidence, Oort theorized that there must exist a gigantic spherical reservoir of icy material at the solar system's periphery. How would this colossal structure have formed? The most accepted theory is fascinating. When our solar system was born 4.6 billion years ago, after the formation of the main planets, there were still trillions of smaller pieces left over, called planetesimals. The gravity of the newly formed planets acted like a cosmic catapult, hurling this material in all directions. Some of it was completely expelled from the solar system, but an enormous amount became trapped in extremely eccentric orbits around the Sun. These objects became so distant that they began to experience gravitational influences from nearby stars and even from the galaxy itself, slowly shaping the spherical structure we know today. Occasional gravitational perturbations send some of these icy objects toward the Sun, creating the spectacular long-period comets we observe. These perturbations can be caused by passing stars, giant molecular clouds, or even tidal forces from the Milky Way. An impressive example happened about 70,000 years ago,
When Schultz star, a binary system composed of a red dwarf and a brown dwarf, passed by the outer region of the Oort cloud. Fortunately, being a low-mass system, it didn't cause catastrophic perturbations, but simulations suggest it may have sent some objects in our direction. The Oort cloud probably has two distinct regions, an inner one that's more flattened, similar to the shape of the Kuiper belt, and an outer one that's perfectly spherical. In total, this structure extends from approximately 2,000 to 100,000 astronomical units from the Sun, more than 1.5 light-years in diameter. To put this distance in perspective, consider the Voyager 2 probe. After more than 45 years traveling through space at 35,000 miles per hour, it's only 139 astronomical units away. Even at this impressive speed, it would need more than 300 years just to reach the inner edge of the Oort cloud, and another 30,000 years to cross it completely. Some scientists question the existence of the Oort cloud precisely because we've never been able to observe it directly. In 2019, we discovered our first confirmed interstellar visitor, Comet Borisov, which had a different chemical composition from comets in our solar system, suggesting external origin. This raised questions about how many comets really come from the Oort cloud versus interstellar space. But why can't we see this gigantic structure? The answer lies in size and light. A typical Oort cloud object is approximately the size of Mount Everest, but it's hundreds of millions of miles away. It's literally like trying to find a needle in a haystack the size of a continent. More crucially, unlike stars and galaxies that emit their own light, Oort cloud objects are completely dark. They're too far from the Sun to reflect enough light that we can detect with our current telescopes. Despite these limitations, the vast majority of astronomers accept the existence of the Oort cloud based on decades of indirect evidence and sophisticated mathematical models. The theory perfectly explains the behavior of long-period comets and continues to be confirmed by new discoveries. Remember that science often advances through theories based on indirect evidence. Copernicus and Galileo proposed that planets orbited the Sun without ever having directly observed this movement, basing themselves only on orbital patterns. Today we know they were absolutely correct. Similarly, our understanding of the Oort cloud continues to evolve. Future space missions and more advanced telescopes may finally allow us to directly observe this mysterious frontier, or perhaps discover completely new explanations for the phenomena we observe. Until then, the Oort cloud remains one of astronomy's most fascinating enigmas, an invisible wall guarding the secrets of our solar system's confines. Thank you for embarking on this cosmic journey with me. If this video expanded your vision of space mysteries, don't forget to leave your like, subscribe to the channel, and activate notifications so you don't miss any incredible discoveries. And since you've made it this far fascinated by the limits of the solar system, I'm sure you'll be impressed with our suggested videos. Click now on the video that appears on screen and continue exploring the universe's greatest mysteries with me. Until our next space adventure.